Hi, my name is Annabelle Prena Anak Janang and my metric number is 73352. So first of all, for this experiment video, I would like to explain on this schematic diagram that has been given to us. So as you can see here, we have a 1.5 volt voltage source that is connected to a 1 kilo ohm resistor, and they are connected in series. So this 1 kilo ohm resistor I call R1. And then we also have two more 1 kilo ohm resistors that are connected in parallel, which I call R2 and R3. So first of all, I simplified this circuit by combining the R2 and R3, which are connected in parallel. So we have here R2 multiplied by R3 divided by R2 plus R3, and that gives us 0.5 kilo ohms. So this is my simplified circuit. So from here we can say that the total voltage of this circuit is equals to 1.5 volts. We find V1 by using VDR. Then we have V1 is equals to 1 volt. Next, we can also find V23 by using VDR. So that gives us 0.5 volts. And as we all know, elements that are connected in parallel have the same voltage value. Therefore, V23 is equals to V2 is equals to V3 and is equals to 0.5 volts. Okay, so now we're moving on to current values. So to find the total current, we can use Ohm's law because we already know the total voltage and we can calculate the total resistance. So I total will be equals to V total divided by R total. So that gives us I total is equals to 1 milliamp. And then we can use Ohm's law as well to find the partial current. So I1 is equals to 1 milliamp. And then I2 is equals to 0.5 milliamp. I3 is equals to 0.5 milliamps. Okay, so now we are going to build the circuit. But first of all, I will be measuring the actual values of the resistors. And then I will be measuring the actual value of the battery. Okay, so now I'm building the circuit. Okay, so R1 is here. And then I connected one leg of R2 in the same column as one leg of R1. This is because in the circuit, R1 and R2 are connected at the same node. Okay, and then I connected R3. So R3 is in parallel with R2, so that's why I connected it using jumper wires instead of connecting it in the same column. So now I'm connecting the voltage source. So this is my finished circuit on the breadboard. Now I'm going to measure the partial voltages. I am not going to remeasure the total voltage because we already know that the total voltage is equals to the voltage source. So here I am measuring V1, and this is the value of V1. Next I'm measuring V2. Here is the value of V2, and then I'm measuring V3. And this is the value of V3. Next, I will be measuring the total current. We know that elements in series have the same current value, so therefore current will be measured in series and not in parallel, like how I measured voltage just now. So I will be opening the jumper wires to measure current. So this is the total current for this circuit. Then I'm measuring I1. And then this is I2. I open the jumper wire to measure I2 and I3. So this is I3. Okay, so now we have the theoretical values and also the measured values. It's time to compare these two values. As you can see from these values, they are not really much different, and if there are any difference, they are only like a little bit different lah. It's like not a lot of difference, which I am honestly happy about, because that means that this experiment was a success. Even though there are slight differences in the values, but the measured values are actually very close to the theoretical values, and these values also prove the theory right, which is in series the current values are the same, and in parallel the voltage values are the same. So I guess that is all for this experiment video. I actually gained a lot of knowledge from doing this experiment. Even though I am not in the lab, at least I can experience experiment like this at home. And it took me a while to know how to connect the circuit in a breadboard, and overall it was good. Alright, so that is the end of this experiment video. Overall, I can say that I have learned a lot of things through it, from building a circuit on a breadboard to measuring the values on a multimeter. And yeah, that is the end of this experiment video. Bye bye.